Hey students, this is Professor O, and here I'm going to talk to you about our other subderivation rule called Negation Introduction. All right, so this is a really tough rule to use. This will be the hardest rule to master. So we're going to go over this in some good detail today to help you really understand how and when to use it. Right, so in order to give you an example of how negation intro works, let's just actually start with like an informal argument. All right, so here we're going to have somebody named Truther, and Truther is going to claim this, that 9/11, the terrorist attack, was an inside job, and that means that the government was behind it all, right? So, you know, when the Twin Towers were being built, there was a government agency that lined the buildings with explosive charges, right? There's no way a plane could take down the towers. This was all to start a war in Iraq and get some oil. Okay, so that's the claim that Truther wants to make. Now there's somebody named Skeptic who objects to this, right? But instead of just kind of yelling at Truther, what he does instead is says, okay, let's suppose you're right, right? Let's suppose you're right. Then, all right, what follows from the assumption that we're going to grant you here is that the deception of the American people is the result of a competent and well-organized government, right? But everyone knows that the government is not competent and not well-organized. So you just can't possibly be right, Truther, right? And so you might conclude then from this sort of argument that 9/11 was an outside job, meaning it was not an inside job. Okay? All right, so that's how the dialectic of that little conversation goes. All right, and what Skeptic is doing here, well, is three things, right? The Skeptic is taking the claim to be refuted, all right? So the Skeptic is going to try to refute the claim, but what the claim is, how the claim is received is that it's assumed for the sake of argument, right? So we're not just saying, hey, you're right, right? Rather, we'll say, okay, let's suppose you're right, all right? And then tease out the implications of that claim, and then show how they are at odds with the truth. Okay, once you're able to do that, then the claim is refuted. Because if a claim entails a false claim, suppose there's an entailment relation between a claim and a false claim, then that claim, that original claim, has to be false. Remember, that's how entailment works. You can't go from a truth to a falsehood. So if you end up in a false place from a single claim and there's an entailment relation, then that claim is false. Right? That's an old idea of logic. It has a Latin name. Believe it or not, this is an argument strategy that's pretty ancient, and it's called reductio ad absurdum. Right? What the strategy of reductio does is establish the truth of a claim by deriving an absurdity from the denial of the claim. All right, so a claim is either going to be true or false, right? And suppose you're trying to establish the claim's truth. Well, you consider the claim's falsehood, and then show that derives a falsity, and so that the negation of the claim cannot be true, and so therefore the claim is true, right? Recall in the beginning of the course, I kind of ran you through a little informal proof about why the form P arrow P is a logical truth. And I said, well, okay, suppose that P arrow P is not logically true. Okay, so we're actually gonna test the falsity of my claim. Remember, or the denial of my claim. We're gonna test the denial of my claim. The claim that P arrow P is logically true. That means then there's going to be a model where P arrow P is false. Okay, and so that means then that there's going to be a model where P is true, and the consequent P is false, which is absurd, right? You know, a claim cannot be true and not true at the same time and the same sense. That's not going to fly. That's not going to work. All right. So that's totally absurd, and so therefore P, arrow P, is logically true, meaning there's no model where P is true and P is false. All right. So that is an example of reductio ad absurdum. And so formally speaking, we can capture this in negation introduction. If an assertion tails a logical falsehood, then that assertion is false. So our job as logicians is to show this. So we're going to need a rule that allows us to make an assumption for the sake of argument. And then we're going to derive a logical falsehood in the form of a contradiction, right, from that assumption. Right, so we need a rule to do that. And negation introduction does exactly this. Here it is. There's the little icon that you need to memorize. Okay, so what's happening here, let's just take a look, right? This is negation intro, so it's an introduction rule, right? So we only have two rules in our system that make us make assumptions, right? And that is arrow introduction and negation introduction. And so that should tell you something straight away, is that if you want to introduce an arrow or a negation, you have to make an assumptions, okay? In no other rule do you make assumptions. None of the elimination rules. Okay, it's only these two introduction rules, arrow intro and negation intro. All right, so keep that in mind. So what you're doing here then, if you're going to do this, right, what you need to do is assume whatever it is that you want to introduce a negation on. Remember, the target down here, right, is not P. So you want to introduce this negation onto a bare P. So that's what you're going to assume, right? Okay, so then you got to do some work, right? You got to do some work, and then on the last line of the subderivation here, you have to derive a contradiction. And the contradiction always has this form, Q and not Q, right? That's always what a contradiction looks like in this class and in our language, right? What this is saying is that Q is true and Q is not true, right? That's absurd, okay? And so that's how you have to do it. Now you're going to have to use ampersand intro to get this, right? So you do need to use ampersand intro to fulfill the requirements of negation introduction most of the time. I mean, usually contradictions aren't given to you, right? But they can be, just like in this problem here. Suppose you have a contradiction as a premise. Which is kind of a weird thing. We usually assume that our premises are true, right? But we know that this is not true. But anyway, don't worry about that, right? What I want to demonstrate, right, is that theorem and logic I was telling you about in a previous lecture in the beginning of the course, that everything follows from a contradiction. Well, that's certainly the case. All right, we can capture that in our derivation system. Suppose we have a contradiction given to us as a premise, right? You can assume whatever you want then for negation introduction, right? You could assume FA for negation intro. You repeat your contradiction. All right, now you've satisfied the rule. Remember the little repetition rule I taught you from last lecture, all right? Use that repetition rule. You just grab premise one, put it on the last line in your subderivation there. Now you've derived a contradiction from FA, okay? And now you stop the subderivation and cite lines 2 through 3, negation intro, and notice that I put the negation on the FA, okay? Right, so that's just fine. Same thing here. You can actually derive FA from this as well, all right? So what you have to do then, how do you do this? Right? How are you going to do that? Well, what you do is you assume the very opposite of FA, which is not FA. Okay, you assume not FA. This is what's really actually kind of hard about using a negation introduction, is that the assumption that you have to make is always going to be the opposite of the target that you want to derive. So in this case, the opposite of my target FA is not FA. Right? So when I'm using the word opposite, right, I'm kind of talking about like what's not the case of your target, and that not is always going to be signified, right, by a negation. Okay, or if if you have a not FA, well then you just assume the opposite of that. That's going to be FA. Okay, so anyway, here we have our assumption, right? You do the repetition rule again, and now what you derive, right, is not FA. Okay, because the only thing you can do with this rule is introduce. It's all you can do. All you can do with this rule is bring in a negation. Right? It's a very common mistake for students to actually strip the negation off and just write FA here, and that's not. You can't do that. Okay, because you have to introduce a negation, and that's exactly what we do. We introduce a negation on to the not FA. Now it says not FA, but guess what? We have a handy little rule that allows us to take two negations off in negation elimination from line 4. Right? And if you remember, that is keeping with that tip that I gave you, is that whenever you want to derive an atomic, your last line is going to be an elimination rule, and it is in this case. Right? Now, we had to use negation intro in order to get, right, the double negative, so we can use negation elimination. Okay, so everything does follow from a contradiction, because you can assume whatever it is that you like for reductio. Okay, and we'll talk a little bit more about what it means to assume something for reductio in the next lecture. Right? Now, the big question with this rule is just how do you know what to assume? And the answer, like I just said, is that it's the very opposite of what your target is. Okay, and you really should not like the very opposite of what you're trying to prove. Right? What the opposite of what you're trying to prove, right, is the negation of what you're trying to prove, and you want to eliminate that from any kind of contention. Okay, so I have a little silly phrase here. I don't know if this will stick. It's a little mnemonic device, but if you don't like it, then put a negation on it. Okay, and so you should not like the very opposite of your target, so you should reduce it to the absurd if you have to, and if you can. Okay, so here is a problem. Okay. Now notice that our target here, I don't look at the premise, who cares about that, right? Let's look at what our target is, and notice what the main connective is. It's a negation, okay? It's on the outside of that conjunction, and so since that is the main connective, and we can't eliminate for that anywhere in our premises, we only have one premise, and it's an arrow formula, we are going to have to introduce a negation, all right, on the last line. Right, so we are going to be using negation introduction. Right, so we want to get on the last line a not, FA, and GA. Now, how do I know what to assume? Well, you just assume the unnegated form of your target. So you're going to assume FA and not GA. That's perfectly okay. You don't have to assume just an atomic, right? You can assume something big like that. That's okay. Right, now, here's something I want you to notice. All right. Because you're thinking, okay, great, I assume that. Now what do I do? All right, what you gotta do, and this is what. So, like I said, what makes this difficult, hard to use, is that you have to assume the opposite of your target. That's kind of counterintuitive. Here's the other thing that makes this rule hard to use. You have to develop an eye for seeing contradictions in the making. Right? Now, if you haven't noticed it already, you can see a contradiction in the making right there. In line 1, you have GA, and in line 2, you have not GA. Such that if you could get these two together, the GA and the not GA, you could derive your contradiction, and then you could infer, right, that FA and not GA is not the case. You could put a negation on the formula. All right, so what we want to do is try to get those two together with conjunction introduction. All right, so let's get the first part of the contradiction right away. We can just pull that out of line 2 using conjunction elimination. All right, so there's one part of the contradiction. Now we got to get the other part. We got to get that GA. Right? Now, we can get GA so long as we have FA. We can get GA if we have FA. Right? And we can get FA out of line 2 using conjunction elimination. So let's do that. Right? Now we can do the conditional elimination, right, on lines 1 and line 4, right, and get GA. Okay, now I have my contradiction. Okay, I have it on line 3 and line 5, so I'm going to use conjunction introduction, put them together like so, right, and now I've derived a contradiction from the assumption that I made. Okay. And so what I'm going to do now is I'm going to discharge the subderivation. I'm going to move to the left, stop the indentation, and write not FA and not GA. And I'm going to cite the whole subderivation lines 2 through 6. That's why I use the little dash there, write negation introduction. Right, so that's a nice little example of how to use negation introduction. Right, so if you're having trouble understanding this rule, this is a nice little problem to come back to. Let's talk about another argument form called modus tollens. I've talked a lot about modus ponens. You should know that by heart right now. Modus tollens, it works in a similar way in that it does have a conditional in its premise. So you have the familiar if P then Q. Now modus ponens would say P and then you would infer Q. Okay, but modus tollens is different, right? At the second premise in modus tollens, we'll say something like not Q. Right? So from this, you can conclude then that not P. Right? So if P, then Q, not Q, therefore not P. That is an argument form called modus tollens. What's interesting about modus tollens is that it actually shows up all over the place in philosophy. So I don't know if any of you are interested in like the philosophical debate about God's relationship with morality. All right, objective moral values. And this is a really interesting book. It's got like 3 theist believers and then 3 atheist non-believers, and they have this big debate, right? And one of the arguments that they're debating in the book goes like this. It says, if God does not exist, then objective moral values do exist. Do not exist. Oops, do not exist. Right, so you see that? It's an if-then. If God does not exist, then objective moral values do not exist. Premise 2 says objective moral values exist. All right, so that's going to be the negation then of this consequent here. And so then you can conclude, right, that God exists. Right, so it's an interesting argument because it is valid, right? It's a valid argument. So what's debated in the book is whether or not it's sound. All right, so you might think that, you know what, premise 2 is false. Right, because there are no objective moral values. It's all subjective. It's all relativists, and so don't worry about it. Or you might think that it's true that God does not exist, but objective moral values do, and you might have some account for why you think that, why you think objective moral values exist, but God does not. Right, so you're going to tell a story about how that works. Or you might just buy into both of these premises and you have an argument for God's existence, which is kind of interesting. All right, and so look, it's an interesting argument. It's this is in high-level philosophy of religion. Right, this is some serious, legitimate, really powerful, smart scholars debating this. So if you're interested in that book, I encourage you to check it out, see what you think. Okay. All right, so what we're going to do in our class is take a look at how modus tollens can be formalized in our derivation system. Okay, so here we have a premise that kind of mimics the argument we were just looking at. All right, so we have not FA, arrow, not GA, GA. And we're going to try and conclude not FA. Okay, so what do we do, right? I mean, this is kind of like, man, I don't know, right? So FA, well, I'm going to have to use an elimination rule on my last line to get that. Okay, but I don't know what to do about that. What am I going to eliminate for here? Okay, but here's what you got to do, right? You got to develop an eye for this. All right, you can kind of see in your premises how there's parts of a contradiction hanging around. Okay, we got a GA and we got a not GA. So what we could do is we can take a look at my target and say, okay, if that's kind of hanging around my premises, what I'm going to do then is take a look at my target and I'm going to assume the very opposite of it. Right? I'm going to assume not FA for negation introduction. So then the end goal here is I'll be able to put a negation on the FA and then use negation elimination on the very last line. Right? Okay, now that I got not FA, I can get not GA with conditional elimination. So that's going to come from lines 1 and 3, right? And now I can actually reach up and grab line 2, that's a premise, and conjoin GA and not GA together to get my contradiction, right? And now I've derived a contradiction from the assumption that I made, and so I can stop the subderivation, I can discharge it, move back to the left, and on line 6, write not FA. Okay? All right, so that's great. Now I can use the double negation trick, right? The double negation elimination trick, and now I got FA on my last line, and I'm done. That is the argument form of modus tollens, right, in our derivation system. Another classical argument form is called disjunctive syllogism. So the way disjunctive syllogism works, it kind of looks like this. Here's an example of it, right? We have a first premise says either Beatrice is in Barcelona or Biloxi. All right, so you think, okay, there's two possibilities where she could be. And then premise 2 eliminates one of those possibilities. It says that she is not in Biloxi, right? So then you can conclude that therefore she is in Barcelona. Right, it's a classic argument form. It kind of looks like this. You got P or Q, not Q, therefore P. Right, that's a disjunctive syllogism. Right, and that can be represented in our derivation system like so. So here we're going to derive FA. Okay, and we have FA ring GA and not GA as premises. Now you can already see, all right, that you have a contradiction in the works here, all right? But the problem is, if you're going to assume, not FA right away and then try to do the double negation trick, that's not really going to get you anywhere, right? That's not going to work. Right? If you assume not FA for reductio, for negation introduction, how are you going to derive a contradiction? Because here's the problem, okay? Part of your contradiction, I mean, you kind of see it. You got a GA here and a not GA there. And so you might think, well, what I need to do is extract this GA out of here. But if you could do that, why couldn't you just extract the FA out of here to begin with and be done? Okay, so when we're talking about extracting stuff out of a disjunction, all right, we are going to be using disjunction elimination. Okay, this is actually what we're going to use on our last line. Okay, now you might be thinking, well, where does negation introduction get involved with all this? Well, that's going to come later on. All right, let's just kind of work backwards here. What we want to do is extract FA out of line 1. All right, and so let's get disjunction elimination up there like I already have, right, and see what we need to do. Now we have a disjunction to eliminate on line 1, right, so that's one of our subtargets, and we got that as a premise, so that's good. Next thing we got to do is get a P to R. And R is FA, all right? R is FA because that's the target. That's what we want to derive in our very last line. So what we're going to need then is a P to R, which is going to be an FA, arrow FA. All right? So we need to get that. And we're going to have to create that, right? So we're going to have to actually use conditional introduction here. And then we're going to have to get a GA, arrow FA. Okay, so those are the 3 things that we got to get in order to get FA on our last line, right? So let's just kind of get cracking here. We already got the disjunction as a premise. So let's create the 2 conditionals. All right. So let's start. Let's pull that up. That's conditional introduction. So remember that rule. Whenever we want to create a conditional, we assume our antecedent. So let's do the FA arrow FA one first, because that one's actually pretty easy. What you do is just assume your antecedent, so you start a subderivation. You assume FA because that's the antecedent of the conditional that you want to derive. And then you can derive FA from itself by using the repetition rule. Okay, so now FA is that's the Q part here, if you were wondering. They can be identical, that's okay. And so now you've derived FA from FA, you can discharge the subderivation, right, and write FA arrow FA then, lines 3 through 4, because that's the subderivation that justifies it, and then write arrow introduction. Okay, so now we have 2 of the subtargets. So we got this one and we got this one. Right now, we gotta make GA arrow FA. So we gotta do conditional introduction again. All right, so you would think that, what I'll do here, okay, I'll assume GA because that's what the rule tells me to do. I assume my antecedent. Right, now I need to derive my consequent. Now, here's something you might be tempted to do. You might think, well, I got an FA right up here. right on line 3. And you know what I'm going to do? I'm just going to grab it. I'm going to use my repetition rule and be done. But that is a mistake. You can't do that, okay? And that's because lines 3 and line 4 too have been discharged. It was closed on line 5, right? So this is no longer accessible to you, right? So the only thing that you can use in an open subderivation, right, are assumptions that you've made above it and premises and other lines too that you've derived, like line 5, right? So this one's accessible, right? This one's accessible, this one's accessible, okay, and then these two, all right? So let's kind of go back to this and just take a look at what we're going to do. Okay, our goal here in this subderivation is to derive an FA, okay? The problem is, though, is that there's no straightforward way to do that. I mean, isn't that what we were trying to do all along? Okay, but notice now, okay, and this is where you have to have an eye for this, folks. This is really tough, right? Notice on line 6 you have GA, and line 2 you have not GA, right? Those are two parts of a contradiction, and they are accessible to you, all right? So if you have a contradiction that you can easily form, now you can use negation introduction and get exactly what you want. Right? So what I'm going to do is that I am going to assume the very opposite of my target, which is FA. The very opposite of FA is not FA. So I have to do a nested subderivation here. So I have to start another subderivation inside of a subderivation, but that's no problem. The reason I'm doing this is so I can derive a contradiction. Right? And I make a little note to myself, why do I assume this? Well, for negation introduction's sake. Okay, now I derive my contradictions from lines 2 and 6. Those are accessible to me. Okay, all right. This subderivation is not closed, right? So I can grab that. That's okay. All right, and I can make use of that, and I can grab the premise as well. Okay. Okay, so now I've derived my contradiction. All right, and so now, right, I can stop the subderivation, go back to the left, and now I'm in this subderivation here. Okay, and you might write FA. But that would be a mistake, okay? Oh, it's such an easy mistake to make. What you have to do instead, right, is remember that you always introduce. You always, always, always introduce. So what you have to actually write is not FA, okay? You have to write not FA. Now you can use the double elimination rule. Okay, now you've derived FA from GA, and so now you can close out that subderivation that you started on line 6, right, and write. Okay, now you're back within your derivation. There's no more subderivations. They're all closed, and you can write GA arrow FA. And that came from line 6 through 10, okay, in arrow introduction. Whew, all right, so now I got all 3 of my targets. I got my disjunction and my 2 conditionals, okay? And so what I can do on the very last line then is apply the rule of disjunction elimination, and I can write on line 11 FA. And that's going to be lines 1, 5, and 11, disjunction elimination. Okay? So you might be thinking, oh my gosh, I will never be able to write that much. It's not fair, right? You might feel this way, right? But you have to remember that practice makes perfect, okay? Practice makes perfect, right? And so you have to practice these, okay? Some things to remember is that you assume the opposite of your target when you use negation introduction, right? So, you know, that question, how do I know what to assume? Well, that's going to be governed by the 2 rules that we have in our system. It's going to be either you're going to create an arrow or you're going to create a negation. And when using negation introduction, you have to assume the opposite of what your target is. Then you got to inspect your premises to see how you can generate a contradiction. And then stay within the scope of your assumptions. Right? You can kind of move up and to the left, but you can't move up and to the right because any subderivation that's been discharged is not something you can use. Okay? All right. Remember to use negation elimination too after you have used negation introduction to negate a negation like not P. And that would make a not P. All right, so what I'm going to do here is actually, at the risk of making this practice problem, well, I don't want this lecture to be too long here. right? But you can see on the slides here that what I do is that I kind of go step by step, is that you work through these one by one, all right, and you get the answer like so, okay? And so you work through it like that. Here you're given a contradiction as a premise, right? You just assume what you want to get, negate it, use the double negation trick, right? And of course they get progressively harder, as you can imagine. So take a look at those, all right? Just try them. I don't want to walk through them with you here because this one's actually pretty tough. I think this is one of the hardest practice problems I have. So, if you get stuck on that one, don't worry about it, right? But, when you're doing your homework, all right, let's pull that up here. Okay. These have you use the negation introduction rule and the arrow introduction rule. So you're going to have to use arrow introduction here. Okay. You're going to have to use negation introduction on this one. Okay. This one is a disjunction elimination rule. Okay. And so those are the hints I want to give you on that. All right, and I think you can figure these out too. All right, if you have questions, of course, let me know in the discussion section of the page, or by email or Hangout. Okay, so I know this is a lot, but I think you can do it, and I will talk to you later.